Hello.
Yes, sir, we are live now.
Okay.
Okay, thank you, sir. Good afternoon, everyone. I'm Jayashree Patil from MES IMCC. I welcome you all on 5 days online FDP on AI for education. Now, let's start with the next session. Today's speaker is Dr. Shailesh Kumar. He is the data scientist at Reliance Jio. He also served as a visiting faculty of machine learning at Indian Institute of Business. Prior to this, he was a distinguished scientist at Ola, co-founder at Third Leap, an edtech AI company, researcher in the Google Brain team, senior scientist at Yahoo Labs, and principal scientist at Fair Isaac Research. Dr. Kumar has over 20 years of research, academic, startup, industrial, leadership, and mentoring experience across various areas of AI, such as in natural language processing, speech processing, computer vision, fleet management, telecom, retail data mining, IoT, finance, insurance, remote sensing, agriculture, education, and healthcare. He has published over 20 conference papers, journal papers, and book chapters and holds about 20 patents in these areas. Dr. Kumar was recognized as one of the top 10 data scientists in India in 2015, top 50 analytics leader in India in 2018, and 10 most influential analytics leader in India in 2020. Dr. Kumar received his PhD and Masters in Computer Science from the University of Texas at Austin and BTech in Computer Science from IIT Varanasi. I welcome you, sir. And today's his topic is Teaching Machine, the Reimagining a Personalized Hybrid Education System. Over to you, sir.
Thank you, ma'am. And thank you everyone for inviting me. It's an honor and a privilege to be here. And today I'm going to wear three hats. One is the hat of a data scientist and see how to look at the education ecosystem from a data science and AI perspective. That is one hat I will wear. The other hat I will wear is the hat of a teacher himself. I teach at ISP, like I was introduced. I've been teaching, and teaching by itself is a passion for me. And I teach online now to thousands of students. And if AICT wants, I can be part of that teaching online efforts that AICT is doing in machine learning and data science. So I'll wear the second hat, which is the teacher's hat, and the third hat I'll wear is the hat of a leadership role in the country, in terms of thinking, working with Niti Aayog and other government agencies to see how we can transform education in India, and especially with the new education policy, what can we do to transform education, right? So, and I'm going to present a few ideas around the work we did earlier in my startup called Third Leap, and also the core philosophy behind that startup, the work we did, and also some of the new ideas that we are working on as part of the Geo's education strategy. So I'll kind of try to put all of this together in this 1.5 hour talk. And we will cover a little bit about AI also, just to make sure that everybody is on the same page in terms of AI by itself. And then we'll also cover a lot more on AI for education, those two aspects. So let me start. I call this teaching machines. So teaching machines is, a concept that was talked about in the 70s by some very prominent AI researchers at the time, and the concept died out, and then we restarted that concept. So I'll talk about what teaching machine is, and how is it going to help the teachers of today, and be like a teaching assistant to the teachers of today. And that is one aspect. The other aspect is, I want to think about a hybrid education system. So after COVID, we all have realized the value of a digital education system where everybody is remote. We're using video conferencing to teach and learn. So everybody is now comfortable with digital education in the post-COVID world. So, one of our thesis is that after COVID, we should not let go of this new learning that we all have had, the new comfort level we have had with digital education. Let us take this forward and use this as an opportunity to come up with a hybrid ecosystem of education, which is both digital and physical together. So that is the main thesis of this talk that we'll talk about. Yeah. All right. So let's first talk about the crisis in education, right? We all understand that there is a big crisis in education, especially in the Indian context, and especially, the lack of effort and leadership in the last 70, 80 years on education and, the state of education in India and, everything put together, right? So if you look at it, even the latest reports, if you will, on our rankings in the country, the QS World University rankings in 2021, if you look at the top Indian institutes that came, the best that came is IIT Mumbai, which is at 172 rank. And there was no Indian institute that came in the top 100 in the world. So we are talking about one sixth of the world population, a country with one sixth of the world population, and not even a single university in India could make it into the top 100. Now that should be an alarm for all of us to say why, what are we not doing right? How can we change this? And how do we get into the top 100, right? If you look at all the universities that are in the top 100, even universities from Singapore, Australia, New Zealand, obviously America, Europe, even smaller countries in Europe, Chinese universities, there's a lot of universities that are there in top 100, but not a single one from India. And that should be a cause of a lot of alarm for all of us in the education space. Another statistic that I want to broadly present is if you look at the number of Nobel laureates that India has produced in the last 100 years, since the Nobel Prize has been given first time in 1901 till today. So we're talking about 120 years of Nobel history. And if you just count the number of Indians who have received Nobel Prize in the last 120 years, a country like India, 120 years have gone by, and we have only, so many Nobel laureates that have come out of India. So obviously, we are not doing something right. That there's a lot of Chinese and Americans and British and Europeans who are in the Nobel list, but very very few Indians compared to what the potential is. And I think we need to really take a hard look at these two facts. And then, obviously, all that has gone into our new education policy, all the thought process. And, every country has to reflect on its own education system that we have created or borrowed, and we are running with it. And, what can we do differently now to change these numbers, right, in the next 10 years, 15 years? And really at the root of it is the reason why we educate our children, right? If you ask any child today, why are you going to school, do you like this, what you're studying, they will say no, they don't want to be here, right? I go to a lot of colleges and give talks on different kinds of topics, how meditation helps students, on AI. And whenever I go to these colleges, lots of students there, and I ask one very important question: do you want to be here? Why are you here? And this, most of them say, I am here because my parents wanted me to be an engineer, or I'm here because I need to get a job. So today, nobody is studying in India for the love of education. Most of us are studying to get a job, to get a salary, to make some money, or to do something, but the love for the subject is lost. And if you ask majority of our students, that is missing. And that is a big alarm for me, at least, that if students are not studying for the love of the subject and only to cross an IIT exam or the next board exam and to get a topper rank and this and that, we are creating a very different kind of education system which is competitive in nature, where we pit students against each other. We are not teaching them how to cooperate, how to do things together. And that cultural effect of that we are seeing in our society. We are all competing with each other more than cooperating with each other, right? So I think there's a lot of reasons why such conferences are very important. Such introspection is very important, that we look at the core metrics of the country and we continuously introspect what can we do. And obviously, the new education policy is one of the most brilliant pieces of document I have seen, which is really going to the depth of what is wrong, what can be changed, how can we really transform this education system. And really, if we all think about the education system we all grew up in, it was created in the British era, where they did not want inventors, they did not want thinkers, they did not want entrepreneurs. They only wanted, workers, clerks. And that is the education system that has been imposed upon India for the last so many years, and we have been going on and on with that education system, right? And this is a good time to take pause, think about the new education policy, think about, I'm sure a lot of you have contributed to that, but how do we take this and make this even more digital, even more AI driven, is the theme. But I think this is a very important point of introspection, that we need to look at why we teach our students, how we teach our students, and what we teach our students, right? All three questions have to be really, really thought about. So I'm not going to go to that depth because there's a lot of great people who have thought about all this. What I will do is the role of AI in all of this. So what is the real problem? If I look at it, and I thought about it when I was at Google, I was thinking, why are we not getting the best people? They don't understand coding, their math skills are weak. We are trying to be a digital global power, but our talent pool is not good enough. So I started thinking about the problems, and then after talking to students, parents, teachers, we realized that the core problem is what we call a one size fits all education system, right? So what is going on is there is one NCRT curriculum or EA curriculum or board, some board curriculum, and all students are supposed to learn the same curriculum at the same pace with the same style of teaching of a student, teacher that they are stuck with in the school. They all get the same homework and they all get the same assessment. So this is a one size fits all education system that we have imposed upon our children. So just imagine that our children can choose the pizza they want, they can choose the movie they want to, watch, but they cannot choose what they should be learning next, what they are interested in, and who they should be learning from, right? And that is not personalized for them. And therefore, what is happening is, we are getting the kind of education quality that we are getting. So that is on one side. The other side, the result of all this is there is no mastery learning. So we all understand mastery learning, that you cannot go to the next level unless you have mastered the previous level. So today, if 33% is my passing grade to go from one class to the next, just imagine a student who gets only 33% marks or 40% marks is promoted to the next level and to the next and to the next. And what will happen to that building? If you start building construction like that and you say 40%, one floor is done, let us move on to the next floor. What will happen to that building? And when these children grow up, by the time they're in the 12th grade, their foundations are weak. And, then they are not good for the high-tech jobs and the technical jobs, right? So that is what is happening because we are pushing them through a curriculum system because course khatam karna hai. That is the main goal of the current system, and that is not working out. 70% of our kids lose interest because, they say, okay, I'm not understanding anything. I have given up on this education system. One more kid is lost because they have given up. And 10% kids who are really good find this unchallenging because for them this is too slow. For the 70%, this is too fast. And the middle 20% are able to cope up with it, right? So this is what happens when we create a one size fits all education system, which is same pace, same curriculum, same content, same homework for everyone, right? Private tuitions are not affordable for everyone, and there's a lot of pressure on performance of the children, right? So we talk about stress, for example, in our students, and there's a lot of stress. We obviously, teachers have stress, but students are a lot more stressed out because they are not given the freedom and the room to kind of grow, and they are imposed upon a curriculum system that is very, very sort of dictatorial, if you will. And the learning is really not happening, and course finishing is happening, but learning is not happening, and that needs to really change. And one of the reasons I got very both anxious and angry about our education system, looking at my own experiences and looking at what is going on in the country. And I was wondering that if we can, we can customize and personalize everything else, right? AI can customize many things. What you watch on Netflix, what you see on Twitter, what you do on Facebook. The most important thing, which is education, why can't we personalize education? And if you look at the current education infrastructure that we have, the approach, the mindset that we have about education, this is not meant for customization. This was meant for producing, factories of workers. not thinkers, not innovators. And therefore we are struggling, and those metrics are highly correlated to this kind of an education system. So with the NEP in place, with technologies in place that we have today, I think this is a good time to reimagine what education could be if we were to start today. If we were to start today, how education could be is a topic worth thinking about. Not carrying the baggage of the past, resetting, and then think, okay, we are living in a world of this, that, and the other. How can our education system be thought about all over from the first principles? And that is what I'm hoping that this talk will kind of create a discussion around. What about teachers? My wife is a teacher. I have been a teacher. So I understand. My mom was a teacher. So I understand the pain of the teachers. And I've seen many teachers struggling, right? So really, teachers are great at teaching their subject, of transferring their love and passion for the subject to the student. And that's the only thing teachers should do. They should not have to worry about, for example, preparing a homework, correcting a homework, taking a test, giving feedback on the homework, summarizing the result, preparing a result, remembering what one student knows, what other student knows, not possible, or personalize their teaching. It is not possible for a human teacher dealing with 30 students in a class and teaching five such sections in a year. It is just not possible for the teacher to be completely focused on just teaching. She has to do so many extra things that are distracting her from teaching, the main thing why she is here, right? So one of the things is, we look at some of the surveys and we found that 25% of their time is actually going in such non-teaching, what I call chores of education, right? Now they have to prepare a question paper or a homework every time there is a test. They have to correct it, which is one of the bigger problems. If they don't give proper feedback, there is no learning that will happen. So they have to give very good feedback on every step, which is again becomes a very, very intense exercise. And remembering all the profiles is the main thing, because at the end of the day, teacher and student relationship is that of a iteration and interaction. And that is not coming out, that whatever teacher has learned about the capacity of the students to learn, she is not able to push it back into her teaching in the next class. She should be able to adapt her teaching according to the feedback from the test. And sometimes it is happening, sometimes it is not happening. Not all teachers are able to do that well. So therefore, there is no connection between what the teacher is trying to teach and what the student is able to learn. And that connection is not there. Therefore, the distance between teacher and students keeps growing, right? So how do we address the dilemma of the teacher and the dilemma of the students? By combining the new ideas in the new education policy at a policy level and technology that is available to us today. And if we look at these two things together, I think we can do wonderful things. So let's look at the broad spectrum of how our school system looks like and what are the core metrics to look at. So obviously one is quality, right? We have to think about quality of education. Are we at par for the right level? Are our teachers trained well and all of that? And if I take the overall national average of the school system, obviously some schools are very good, some schools are very bad. But if I look at the overall quality of school system education, we are not going to rank it very high. I'm comparing it with Europe, Japan, Germany, and many such countries, right? We are not there yet. Home tutoring quality is medium because they are not the best teachers, but they are at least giving one-on-one attention. So as home tutors come in, they can increase the quality a little bit. Online tutoring has opened up now, so there are a lot of companies that can let you sign up for online tutoring. And then one tutor comes online, the kid is at home, and they spend 15 minutes, 1 hour, whatever. That is a new one more area. And then the massive online courses, open online courses, which is the next wave of education that started 5 6 years ago. Now there the quality is very high. If you look at the quality of teachers in the MOOC courses like Coursera, Udemy and all, they're highly trained, highly experienced teachers, and they have very good content and they produce very good content, right? Same thing is happening now with NPTEL opening up the IIT professors videos. is a great step in that direction, that there is an Indian MOOC system that is emerging and the quality is very high. Right? We need to do the same thing at the lower levels also, like Khan Academy is taking over, and such. Wherever quality of education, even if it is delivered digitally, is high, is acceptable. Right? So quality is one thing. Second is availability. Right? If you look at school system now with Sarv Shiksha Abhiyan and low cost of education, now the availability of school system education is very high, but tutoring is not highly available because they are costly, right? One student, one child kind of tutoring is not available to everyone. But if it was, and if you look at availability, massive online courses are available to everyone. Anybody can sign in with a very low fees. They can actually take the course. If you have access to the internet, you can do it. Scalability, again, a very important issue for the Indian context. We don't have to just educate our urban rich kids. We have to educate everyone at the same level of quality. If that is our goal, then we need to create an education system which is highly scalable, equally accessible to a poor kid from a tier 3 village as to a urban kid in the city, equally available. So unless we get scale into the system, we are not going to do it. Now, if we only think about physical education system, where a teacher teaches a student, scale means more teachers, more quality teachers, more teachers. Every year we are training more teachers. To achieve scale, we have to get more teachers onboarded in a physical, purely physical education system. But in a physical digital education system, we can think about scale slightly differently. Right? Uh, Personalization is very important. We talked about it, and I think that is one of the most important things we can do with education, which is make it highly personalized. And in a school system, it is very hard to do personalization because the teacher cannot remember the progress and the subtle growth of every child throughout the year. It's very difficult. It's humanly impossible. Home tutoring is a great example of personalization, where a tutor comes. It's like a family doctor. If there's a family teacher, then he knows exactly what this kid needs, what that kid needs, and he can really personalize his learning from there. Online tutoring is less personalized because every time if a new tutor comes in, he does not have the context of the previous tutor for the same child. And massive online courses are completely not personalized because they are online. There's no personalization there. Once the video has been created, it is done, and now it's the student's responsibility to watch and learn from the video. Right? Affordability wise, I think massive online courses are highly affordable compared to our tutoring and online system. So if you look at some of these criteria and think about what is good and what is bad in each of these different types of tutoring experiments that we have done so far, and rethink what education would look like if it was born today. So that is our real challenge today. And how do we go there? Right? So the idea is that education content is becoming easier to create and distribute now, right? So in COVID time, we have learned how beautifully our teachers are sitting at home, creating content, putting it online in Google Classroom and everywhere. Almost everybody has devices and connectivity now. Even in villages, we have some kind of a phone, if not a smartphone. So there is almost universal connectivity through telecom companies and what have you, through government initiatives. Cloud is available now in India, so we can put massive amounts of content on the cloud, question banks on the cloud. We can scale really. Scaling is not a problem. Digital scaling is not a problem. And AI is ready to deliver personalization. This is the context from where we should start thinking. If all this is available, if content is easy to make, high quality content is easy to make, everybody can access it through connectivity, there is no problem of scale, and AI can actually improve personalization. If these four pillars are available to us, how can we bring in a new experiment in education that allows the freedom and personalization for students, and at the same time take advantage of the fact that we have millions of trained teachers around the country? How do we create a hybrid education system given this context is where the next thought process is. So now let me give a quick overview of AI from my perspective. This is not AI for education. In general, I will talk about AI so that we all understand AI, what it can do, what it cannot do. and how it can help us in the education domain. Then we'll come back to AI for education. All right. So, if I think about the universal journey of artificial intelligence, any system in the world that adopts AI, whether it's agriculture for India, education for India, startups, big companies like Google or Reliance, they all go through the same four stages, right? So the first stage is what we call the infrastructure stage, where they build the core infrastructure. Like in the schooling world, our infrastructure is all the schools we have built, universities we have built, all the departments, all the labs, all the teachers we have hired, all the equipments we have done. All this is infrastructure. So we now have reasonably good infrastructure. Uh, Obviously, everything can be upgraded with time, but infrastructure stage we are good at. Right? The next stage comes is automation, and I think this is where one of the things has to happen, which is can I use now IT systems to automate some of the stuff? So in the schooling world, we have automated, for example, the application process. You can apply online, or we have automated how the grades are given and distributed to students, how the attendance is tabulated, how the school administration is run, how the school buses are controlled. So we have brought in a lot of automation in the peripheral aspects of education, and now we need to start seeing how can we automate the core aspects of education. For example, which homework question to be given to which student, can I automate that? How do I correct the homework with multiple choice answers? Can I automate the homework correction, for example, right? How do we bring automation into some of the things so we can scale our teachers to do more important things than correcting and creating homework? So what does automation mean in the education world? In the core aspects of education, we need to start thinking. So that is generally the second stage that helps us. This is more of an IT transformation of that vertical. The third is the data vertical. And this is very important in education. What is happening today is, if you look at why e-commerce, for example, right, retail, or why Google search, those are the places where AI has really picked up. And why not in education and healthcare and agriculture and other social sector? Why has AI not picked up in those areas? And really the problem is the data. And when we talk about data, I'll give examples of that. But in education, there is a very important kind of data which we need, which is not being collected in a physical education system. If a child is going to do homework on a paper and pen system, and only that homework is collected, corrected by the teacher, seen by the parents, and at the end of the school, that notebook is lost in the trash can, all that data is lost. We don't know what problem the student solved, where he struggled, what kind of help he needed, what kind of mistakes he's doing. All that is not logged in a digital system because it is written on a physical notebook. Think about this. If the data layer is not strong enough, we cannot do much on the AI layer. So we need to start thinking about innovative ways of thinking about data collection, right? And then, obviously only then these companies, these institutions start to think about AI. So this journey is very common. Ola, Uber goes through this journey. Refineries go through this, telecom goes through this, retail goes through this, agriculture is going to go through this, our governance will go through this, our digital payments will go through this. Everybody will go through this journey. And what does this journey mean for the education space? We have to really think about. So infrastructure we understand, but automation we are probably 30% there. Data we are probably 5% there, and AI we are probably 1% there. So there's a long way for all of us to go there, and we need to think about that. Now, within the AI journey, there are four stages within the AI journey. First is reporting the past. This is what we call the business intelligence. And in the education world, what that means is, can I slice and dice my results by school, by classroom, by section, by teacher, by area where kids come from? Can I slice and dice my results and come up with beautiful reports and say how are my students doing in the past, right? So so many exams have happened, these are the grades taken, this is what has happened in the past. So I can do that very well today, but that to me is the first stage and the most useless stage. but it needs to be done so that we know that we are collecting data and we are able to look at insights from that data. At least we need to get that comfort level to know where we stand from a objective point of view, and say this is digitally stored, all the exam results, every problem. I know what you did, what you scored. It's at a very detailed level, right? So I can do analysis on it. This is the first stage in AI, which is reporting the past or business intelligence. Now, that is not enough. Why? Because in AI, we don't only look at the past and summarize the past, we need to be able to predict the future. And this is where the birth of real machine learning happens, which is, can I predict something? Like in telecom, I want to predict whether this call will go through or not without any call drops, is a model in telecom. Similarly, what is the core model in education? There are two, three core models in education. One of them is, let's say I want to do homework personalization. One of the core models is, if I give this problem to this student at this time, that means at this stage of his learning, will he be able to solve it or not? That's an example of a prediction problem. And AI can really do it if we collect all the data from the past and we build models on it. We can really predict which problem which student can solve given his current state of learning. And that can be used to do problem personalization and homework personalization. Why? Because I don't want to give a student a problem which is very hard given his current state of learning, or very simple given his current state of learning. We want to give him only that problem that is 50-50% chance of solving, not 90% chance of solving or 10% chance of solving. If I just take that one example and say, look, this is how AI can help transform adaptive learning in education, create a different homework for every student, because we are able to predict what problem they can solve well, easily, difficultly, or just right. Right? Now, if I can do that, the next thing that I want to be able to do is not just predict the future, but create a future. So if I know that giving him this problem is going to demotivate him too much, he's not going to be able to do it, or giving him this other problem is going to, make him bored, I need to now pick the right problem to give. That is the action. So to me, data science is a layer of actions on top of a layer of predictions. So I predict that this student is going to fail this exam is a prediction, but action is, therefore I need to give him more of this, more of this, more of this, is the action. So how do you convert prediction into action is the next thing. So machine learning to data science. And the last thing is what we call artificial intelligence, which is not only look at the current state and the current action and the current prediction, but also look at all possible learning paths and say, if I took him through this learning path in the long term versus this learning path in the long term, will his efficiency of learning be much higher or much lower? So that is what AI is really promising us for doing. It can actually create a unique learning path given where the student is. It is like a Google Maps, right? If you want to know where the destination is and where I am, Google can give you the optimal path, if you will. Same thing can we create for every student is possible now with AI, right? So these are the four stages of AI adoption in any field. And I'm giving example of AI adoption in the education field. And these are just examples of what it means. So we have to get to, business intelligence layer. But before we get there, we have to solve the digitalization of education problem so that kids are not doing homeworks on, physical copies anymore. They're doing homework on a digital slate. And today the government can fund this, the NGOs can fund this. Every village, every city, everybody has an iPad or some kind of a device. Online test taking, online homework uh, is going to create the data that we need to understand every student's pain points and be very precise about what every student needs and how to customize the next thing for them. Yeah? So at a very micro level, not at a board exam level, we realize, right? At every stage, we can do this without adding any extra burden to the teacher. The key is, if you digitize everything like this, no extra burden on the teacher. The data is automatically digitized, and I'll show you how teacher can control what test to give, but AI can adapt on top of it even further. All right. So next, let me talk about a universal architecture of AI. Again, this is important for all of us to understand how AI top down, how can we think about it, right? There are bottom up things I don't want to talk about, but because we are all teachers and domain experts, we will understand these terminologies very simply. And this is a top down architecture of AI that we all think about when we think about any new area in which to deploy AI. So AI is really a four-stage process. It's a stimulus, thinking, response, learning. These are the four stages in AI. Stimulus means what is it that is coming to me? Like, stimulus, right? The sound I hear, the things I see, stimulus. So stimulus is the first thing, and we need to create a very robust stimulus layer. So what does stimulus layer in education mean is when a student is watching a video, content of a video, and he's pausing somewhere, rewinding a video, again watching it, and if many students are doing it, what does that tell me? That tell me that that part of the video is needs improvement, right? This is exactly what a teacher does. When a teacher is teaching in the classroom and she looks at the face of the students and she sees that they are all confused, teacher exactly does the same thing. She will pause, she will go back and teaches the whole thing all over again in a different way. This ability is possible now if we build the right stimulus layer, which is, imagine a system that you're watching video and the system is watching you through the camera, and now it can do facial recognition and figure out that you look confused, you look sad, you look angry, you look happy, you look normal. It is possible now. And now the video can pause, play, replay, rewind automatically given the feedback it is receiving from the facial expression. That is an example of a stimulus layer. Another example is if I'm giving students the problem to be solved on the digital media, and I look at, they have to write every step in the math problem, and they write a step, then they take a lot of time between the step one to step two, then I know that the concept that is needed to go from step one to step two is not something the student is comfortable with. I can understand that because he's taking too much time or he's taking a hint. So the level of detail at which we can collect stimulus data is going to define the degree of AI we can do with them. So I think we need to put a lot of thought when we create these digital systems for education. These are not just systems to deliver content or to deliver problems. It is also a system to collect feedback, implicit feedback. And that is the foundation of how Google and Netflix and all these companies work. They collect a lot of implicit feedback. So that is the stimulus layer. The second layer is we analyze the stimulus layer. We say this student did this problem, he took this much time, the average time was this much, he still got it wrong, and he spent most of his time on the fourth step. If this is the level of detail that we log today in our education system, we can analyze it and come up with a state representation of a student. So state thinking is very important in every domain, and we'll talk about this. So what is the state of learning of a student? How do I characterize it? So if I look at all the topics that he is supposed to master, and if I look at how much effort he has put into this topic, how many problems he has solved in practice, how many assessments he has cracked without any problem, how many assessments he needed help, I can come up with a score, a learning score, an effort score, a retention score, a knowledge score, an application score. I can come up with five types of score at every fine-grained topic, like Pythagoras theorem or what have you. I don't have to think about physics, chemistry. I can go into very, very detailed, topics, and I can come up with a very detailed scorecard based on the activity. If he has watched one more video of a certain activity or concept, we increase the effort score. If he has taken more practice in that, we increase the practice effort score. Like that, the digital system is continuously monitoring the state of the student in a very private setting, uh, you know, and using the state and improving the, monitoring the state. Once you have monitored the state well enough, the next part of AI is really about taking the optimal action given that the student is in this state. So we use domain knowledge, we use all the metrics that we care about, and say what is the next best action if the student is in this state, versus this state versus this state. So if a student has already done well in certain topics, I can recommend he can move on to the next topic. Or if he's struggling with a certain other topic which he's supposed to know by now, I can say, no, no, you cannot go forward unless you have mastered the previous topic. So I can now create a different learning path for every student because I'm giving the right action at the right state of the student. And then we synthesize that through the digital system or through the teaching ecosystem. And I tell the teachers, look, these 5 students need help in this very, very specific topic. They don't understand minus of minus is equal to plus. They don't understand that. How did I figure this out? Because in all the math problems, whenever this concept is there in step number 3 or step number 7, they only make that mistake. Everything else they are doing okay. So I can do step level feedback and know exactly what is wrong with exactly which students and tell the teacher that these students need a special attention on this concept. And now imagine the idea of a section. There is no section ABCD now. There is no static section in the school. Sections are created based on the need of the students. A group of students who need to master a particular concept, next morning they come in, they are told to go to that section, the teacher goes to that section, they spend 15 minutes, teacher only teaches that concept and they come out. This is the connection between physical and digital. The digital figures out the issues and the physical addresses the issue, right? And all that. And then what will happen in an AI system is we may still not get it right. We may get a feedback that, you know what, I told the student to watch this video, he was in this state, he was watching the video, he still did not understand. So the feedback says this video is not good for this student, I need to give him some other video, or I need to send him to another human teacher to teach. So that feedback is now used to improve all these 3 systems. And now the like a teacher learns how to teach as they experience teaching with students and they also learn how to teach, the AI system will also learn how to teach better. But the difference is a teacher can only teach so many hours a day, so many students a day. But imagine if a digital teacher, like a teaching machine, is going to teach millions of kids simultaneously, within a day it will collect that much of data to know how to do better next time. And it is learning very, very quickly now because lots of kids it is teaching and it is improving very quickly, right? And now all of the AI algorithms that we create, right? Or you must have, if you've dabbled into AI, there are a lot of different things. So I don't want to talk about that. But really, most of the AI algorithms are really about converting the stimulus data into a state vector for a student. How do you define it? How do you know what is the efficiency level of a student? How do you come up with that number, right? Like in credit world, looking at your transaction data, I convert that into your credit score. So that's an example of stimulus to state. If I look at your Fitbit data and come up with your cardiac health score in healthcare, that is an example of stimulus to state. So stimulus to state is a very important creative process that all of us have to think about. What is the state of a student's learning? What data do I need to collect in order to compute this state? And given this state, how do I optimize the actions? So state thinking is the key to AI thinking. Okay? So that is the point of this slide. Now, how does it work in the real world? How will it work? So let's say we have built all these models, predict the probability of success of a student here, there. How will this work is there's a very simple cycle, very natural cycle in AI, which is as follows, right? So the first step is monitor. You collect the stimulus data all the time. It doesn't matter whether the student is a great student or a lagging student, it doesn't matter. You monitor everything that he does, what videos he's watching, what content he's consuming, is he pausing, is he finishing a video or not, is he frowning when he's watching certain part of the video, is he solving the problem, taking more time, less time, depending on hint, directly doing it, and all that, right? All that. So you monitor everything. Then from monitoring, you discover what is wrong, what is right. So discovery is the next stage, which says, you know what, this kind of question, this kid is doing worse than average, 2 standard deviation, and this kid is doing better than average, 5 standard deviation on this concept. So he has really mastered it. So how do we discover, patterns out of the stimulus data? Then we analyze, why is this happening? If there is a problem that a kid is, not able to solve a particular kind of problem again and again and again, we go to the root cause analysis and say, why is it happening? Can the AI system do root cause analysis? So what it'll do, it'll go to the previous concept, and say, look, he doesn't know minus of minus, therefore he's solving all these problems wrongly. But if I only do multiple choice question and look at, the five answers and try to analyze them, I may not go to the root cause. So to go to the root cause, we have to go deeper into that. Once we understand the issue, discovery, once we understand the root cause of the issue, then we can come up with the best action and say, look, minus of minus is the issue. I have discovered. And now the best action is, let's go back to the fourth grade video, which teaches this, and put that in front of the student. Then again, test him only on the minus of minus, fourth grade question. Then bring him back to the eighth grade content all over again, right? So you can do that in a education system which is very agile, very personalized, and the student does not have to feel judged that he's now learning a fourth grader thing when he's in a eighth grade, but he will feel judged if he's doing that in front of the whole class. So the privacy is preserved, the self-respect is preserved, and the system automatically takes them back and forth, and they can learn and come back again. And then they are confident. Now they are going to surge ahead, right? And then how do we execute this, right? Should I give him a digital problem to solve? Should I tell the teacher that she should teach him? What should I do? And how do you measure impact again? Again, you can say, look, I did this, I discovered this problem, I understood the root cause, I executed this way. Now, is the impact there or not? So let me assess him. And if the impact is positive or negative, we learn, and then we try to improve our own ability to teach by, initially making a few mistakes and then eventually catching up. Yeah. So this cycle is very important. And if we can, this is a universal cycle, by the way. This is exactly how we run telecom. This is exactly how we run retail, agriculture, every field you can run exactly this way, every operational field, right? So we can bring this mindset to education also and run education that way. Now, if I ask people, what education does, right? What AI is doing to all the businesses and all the sectors is only four things. It is helping us make, broadcast decisions to personalized decisions. So the idea is today, our education system is a broadcast system, right? In some sense, because we are looking at all the, everybody is learning from the same textbook, same pace, same teacher throughout the course. It's a broadcast system. Can I make it personalized? We talked about personalized education. It's a batch system. Like every year you're going to give one exam, every mid-year you're going to give one exam. But can I make it real time? Every homework you struggle, I can intervene, right? Every homework, every problem you struggle, I can intervene, because that is the agility and personalization that a digital system brings to the table. Can we not react, but can we be proactive? Can I discover a problem with the student early on and fix it, instead of saying, "Arey wo bacha fail ho gaya," and then we are all worried about it, right? How can we be proactive about our decisions, find the issues early on, and keep cleaning them up? And how can we think about a strategic learning path for a student and not a tactical कि IIT एग्जाम पास कर ले बाकी देखा जाएगा. ये बाकी देखा जाएगा is a big problem in India, and I think we have to work on that. We need to make sure they are not too stressed out and burnt out that they become vegetables after certain time, right? So how do you think about strategically taking them through the right topics to the next level with individual learning journeys for every child? Now, there is a template of AI that we follow, which is very similar to what I just talked about. We define the metrics very clearly. We say in agriculture, for example, the template is, I want to maximize the crop yield. I want to minimize the cost of cultivation. I want to maximize the net income of the farmer. So I have very well defined metrics in agriculture, for example. What are the metrics in education? Is it about 12th grade exam result, 10th grade result? Those are the metrics today. That is not the right metric. We'll talk about what are the metrics we should think about. What is the domain knowledge in that field? So in agriculture, we have a lot of domain knowledge. What is the stimulus data we are collecting? Again, we have a lot of stimulus data we can collect in agriculture, like soil IoT, weather, and all that. What is the state of the crop, state of the farm, state of the farmer, state of the village? All of that I can figure out. And then what is the right response? So think of these 5 things: metric, knowledge, stimulus, state, response. And if we follow the same thing, I'm repeating myself in the slides, I'm saying the same thing multiple ways, so we all understand that there is a template to this also. So what is the template for education? Again, we need to define metrics very differently. We cannot say कि math में कितने आए, physics में कितने आए. That is not the metric. The metric is learning outcome in terms of efficiency of learning. How much time you spent on a topic and what was the result of it. If I teach you a topic at the right time when you are ready for it, you are going to learn it much faster. But if I teach you ahead of your time because you don't know the prerequisites, I'm going to have to struggle with you a lot. Still, you will not get it, and I'll waste everybody's time. So, learning efficiency is an example of a metric that we can talk about. Second is learning engagement. Learning engagement is, you know, does the student want to do more and more because he's enjoying this, versus he's running away from education? Today, kids are running away because they cannot say, I don't know. So they say, I am not interested. We think they're saying, I'm not interested, but really what they're saying is, I don't know, I'm stuck, I don't know how to move forward, this is going too fast for me, I don't know. So that we have to work on. So think about the metrics very carefully, what we have to do. Domain knowledge we have lots of domain knowledge about how to create a curriculum graph, what should be taught before and after, what are the different teaching methodologies, what are the different learning styles. Like some children are very kinetic, some are abstract thinkers, some need real world examples. But if you're not child centric, if we just think about curriculum centricity, we're not going to understand our students differently. We're going to try to teach them the same way. But we have not figured out that this child is different, he will learn differently, this child is different, he will learn differently. That level of personalization has to happen. Then stimulus data we talked about. Again, we need a digital platform to do homework and consume content as much as possible, so that that digital data will help us understand the state of learning of a student along retention, along knowledge application, all of those various Bloom hierarchy dimensions. And then what response, what learning path should he follow, what content he should contain, what practice he should do, and who as a mentor should talk to him, which is the best teacher to talk to him, digitally or physically, to help them, or another student, to get him to the next level. All right. So what we need is, for a student perspective, this is how AI can help, right? He's asking the following questions. She's asking, what concept should I learn next? Don't tell me that everybody is studying this, so I should also study this. No, that is not. If everybody is eating certain kind of pizza, that doesn't mean I also have to eat the same pizza. If they can eat different pizza, why can't they be told what concept they can learn differently? Which content should I consume? Some teachers are teaching in a very different way and I'm not able to connect with them. But because I am in a digital environment, there are 400 types of videos available on the same topic. Can you not figure out which one teaching style will match my learning style? Right? If I can connect you to the right movie on Netflix, can I not connect a student to the right type of teaching content on the teaching library? We should be able to do that. Which problem should I practice? Don't give me very hard, very easy. We talked about it. Uh, Today, what happens? Everybody gets the same homework. How do I proceed from one step to the next step? So the student may need help. At 12 o'clock at night, she's working on a problem. There is no help. Is there a digital system who can help him or her? Right? How do I get immediate feedback on a problem and say, this step I did wrong, others are correct, right? How do I get that level of feedback? And can I tell what is another alternate way of solving the same problem? And this is one of the things about learning the art of thinking versus memorizing the book solution. Can a student see alternate ways of solving the same problem? And if he sees that, his analytical thinking will grow and he will understand why this solution is better than that solution. Right? And where do I stand? Have I really mastered the concept yet or not? Today she's waiting for a board exam result to tell them how good are you in physics. No. Can they learn this very quickly, that where they need to focus on and all that, and what prerequisite they need to catch up. So people are telling them you're not good at this. People are not telling them what you need to do to become good at this. So how do we understand the prerequisite and do root cause analysis? And then, what concept should I review now? We have talked about it. Review now, which is I have learned this concept many months ago. I mastered it many months ago. I may have forgotten it. The system knows when did you master which concept. Can the system say, 3 months later, hey, it's been a while, you have not done geometry XYZ. Why don't you try this and let's refresh, right? Because there's nothing else to do right now. This is the good thing to do. Same thing on the teacher side. How can we help the teacher, right? So the teacher should know, what should I teach next? It's not about curriculum course khatam karna hai, but based on the feedback from the students, and as a collective, she will know that 50% of the students need this help, another 50% need that help. She can break the class into two, focus on this here, focus on that there, right? And this clustering and segmentation of the students based on their need is going to create what I call an adaptive section system, where there are mini sections. They're not ABCD fixed in the beginning of the school, end of the school. They're adaptive. Every week they can change, and the right students who are very similar to each other in their learning journey can be put in one section. And then the teacher knows exactly why this section is created, because these are the students who need this particular kind of help. So she focuses on that when she goes to section A, and to section B, she focuses on something else, because that group is created differently, because that group is struggling with other type of concepts. So same class, she can do different things in different section, because sections are created in a student centric way, and they are agile and changing every week, right? What homework to give? Again, if the teacher does not have to give the homework, imagine if a system adaptively gives homework to every student, how great will that be? Teacher does not have to worry about it. So we'll talk about that. Assessment, if the teacher doesn't have to do assessment, system will do it. System will give feedback also, both to teacher as well as to the students. And the system will tell the teacher, look, this group of students need this help, and we need to work on that, right? And what prerequisites a student is lacking, again, a teacher needs to know. And all this can be digitally done. Teacher does not have to remember the student, correct the homework, give the homework, none of that. The digital system will do it automatically. And then what kind of mistakes the student is doing, again, she can focus on those kind of things. So I think from a teacher and a student perspective, there's a lot that can be done if we break down education into digital part and physical part. Very clean boundaries should be there, right? Like in Amazon, there are very clean boundaries. You order your product digitally on the website, but delivery is physical, right? Unless you're downloading a Kindle book. So digital, physical separation of education has to be clearly thought through. What part of education is better done digitally and what part is better done physically? So here is our overall proposed solution, right? So the idea is, we are ready. 70 years ago, 30 years ago, we did not have a choice. But today we have a choice. We have all the technologies we need. All of this technology is simultaneously available to us. Every child has at least one device, if not two. There is cloud computing for scale. There is connectivity for every child. Internet is there as their library, and AI is there to do data-driven personalization. All this is available today, and if we don't utilize it now, when will we utilize it, right? So this is what the thing is. So now this is the concept of a universal teaching machine. What does that do? So it's a device sitting, it's an app, if you will. Imagine an app sitting on every child's laptop or whatever. It's the learning companion in the absence of an actual teacher. This is the learning, this is like a teaching assistant, right? It's a companion to the student and an assistant to the teacher, because if a teacher cannot be with every student all the time, she is trusting this teaching machine to be there with every student, understanding the student's need, telling that to the teacher, and teacher is now driving the education system. So what does a teaching machine do? It needs to be able to interpret, the formulas the students are writing, the handwriting or the typed thing, the language that they're saying, like in English, Hindi, the system should understand multiple Indian languages, images that they're drawing. All this the teaching machine should be able to do. It should be really able to profile the student and say today or at this stage, the student has this knowledge, this is what he's ready to explore, this is what I need to optimize, and this is what the learning that should happen, right? It should really understand all these aspects. It should be able to personalize everything. It should be able to say, look, I want to personalize your curriculum, the content, the problems I will give you, and even the solution I will tell you is personalized to you. You will understand this solution, not that solution, because that other solution requires a step that I know you are not comfortable with. That is the level of solution personalization that is possible. And then this teaching machine should be able to communicate in speech, in conversation, in gestures, in emotions, like a more human teacher does, right? So all these capabilities are now available as individual APIs in AI. We just have to put them together, and maybe AICT can take a lead, or some organization can take a lead and say, yes, we want to build a teaching machine. All of us can give an input and create the best teaching machine for the whole of the country, for all subjects, for all levels, and say this is what will be available like an NCRT textbook is available from content perspective. This companion is available to all students in all languages, and it will help supplement what teacher is doing, what school is doing, what parents are doing, and it will personalize the education for them. How will it work? So it will basically maintain the state of the student learning. See, like I said, in AI, the most important thing is the state of the student. So if I look at the state of learning of the student, I can say this is the current state of the student learning. And every time he does something, the state changes. That is important. State is a very dynamic thing. He watches one video of one content, his state changes. He solves a problem, he gets it right or wrong, the state changes. So state is a very dynamic thing. And in education, state is continuously changing. So there is a state of the student at this time. He opens the app, it looks at the state and says, this is what you're ready to learn today. These are the topics for you, not what everybody else is learning. This is exactly the topic you are supposed to learn. And I'll show you how will we do it. Then the student says, okay, out of the three, I want to learn this. So then this is the content that you should consume, because your learning style and the teacher's content teaching style matches. This is the right content for you. Then it will give you the practice after you watch the content, precisely the right questions for you. And if one student needs less number of hard questions to finish the practice, or another student needs a lot more easy questions before it gets the hard questions to catch up, fine, it will adapt according to the student's learning and capacity. If the student is getting it wrong, the previous question, it will give the next question which is simpler, and see. If that is also getting wrong, it will give even less simpler question. If that is also wrong, it will take you to another content to watch. So it will do all this for you like a tutor would do, right? We are trying to bring in the tutor persona here. And then it will also let you learn, watch this video, this documentary on National Geographic, this video by this scientist, this talk with this IIT professor, whatever, right? This documentary on space. So there's a lot of additional content that can be brought to the student when he's focused on that concept that he's learning. Yeah. So you don't have to go to YouTube, search for it, decide what. It's pre-created, curated content, additional content created, available in all languages. That is important. Yeah? And then, it'll do very fine-grained assessment of the student. And based on that, it will do analysis of that assessment. And now it'll update the state. So you see the state update will happen as soon as it has analyzed this content you consumed, this practice you did, this extra learning you did, this assessment you took. These are the places of good and bad, feedback. And you analyze all this and update the state. And again, the cycle continues, right? So this cycle is important, and the student is continuously learning through these stages. So let's talk about curriculum and few of these core building blocks, right? So one is your curriculum personalization, and there's a Bloom study that we all know, the two sigma problem, which is if a student is taught in a mastery learning way, that one-on-one tutoring in a mastery learning way, he will learn twice as fast twice as better than top-down teacher broadcast to personalize. So we know that from research. So today what happens? We have a standardized curriculum. Every student is taught the same concept in the same order at the same pace. Whether they have mastered the prerequisite or not, it doesn't matter, and that is my problem, right? So uh, uh, so how do we change that? So that is one thing, and now that is possible because now we can do a personalized learning path for every student. So we are recommending, no, no, you are going to learn this, that guy is going to learn this. You take your time, you learn it, you master it, and all that. Once you have mastered it, only then you can move to the next level. Mastery learning, personalized learning is key here. So here is an example. Imagine there are two students, and one student A has mastered concept P, Q, and R, and this is his current state of mastery of those concepts, 90, 75, 50. Student B has mastered the other concepts differently. So now my question to the system is, which concept XYZ should he learn next? Should they both learn the same concept, or can they learn different concepts? So then we know the prerequisite graph. This is the domain knowledge in education, which we already know that to learn concept X, you must have mastered concept P a lot more than some other concept. So there is a dependence graph that is given to us, and so on and so forth. And really, if we use machine learning and AI or heuristic based system to say which concept can I score all these concepts XYZ for student A differently and student B differently, given the input data, which is the current state, right? And that is what we need to build a machine learning model for. And if we get it right, and if this system is predicting that, look, if this is the state of the student currently, PQR, then XYZ, these are the scores I'm predicting he will do well, student A versus student B. Given the state and given the connection graph, we can make a prediction. Now, when we do the prediction, what will student A see in his personalized learning is, he will see that, look, student A comes in, opens the app, and he will see that concept R he needs to learn because he is very behind on it, and concept X he can learn. So if he wants to move forward, he has a choice. He can learn X because we know that he is ready to learn X. He's not going to fail that. It will be easy for him to learn X. He's ready. And but he also needs to learn R at some point. So we'll keep showing him R again and again till he finishes that. And as soon as he masters R, he will be able to do Y, because R is going to affect Y. So this is student A journey. Student B, we are going to tell him, look, you can either learn Y now, or you have to learn P. You choose. You can move forward, or you can learn this. So this choice is given to the student, which is very deliberately computed, and therefore the student is able to do a good job of moving forward, and he chooses, and his graph updates, his state changes. Again, all that information is available to the teacher. The teacher can decide what to do with that information. Content recommendation, what happens today, if you join Khan Academy also, or Coursera, you have only one piece of content for one thing, or Byju's, right? But India has probably some of the best teachers in every state, every language. And if we can those teachers should create the best content. We can have a marketplace for content. So teachers are creating content online. Students are liking them, not liking them. Automatically, the right content is bubbling up. And then, those contents are getting attached to similar students, right? That kind of thing. So if we can build a recommendation engine for movies and songs and news, why not for education content? And this will basically be driven by student feedback. And now the student can choose the teacher that she wants to learn from based on the content that gels with her versus another student, right? So now imagine a content repository where the system will learn that this is your learning style, this is the teaching style, this is a good match. Students who are like you find this kind of a content nice, so you are also going to like this kind of a content nice for this concept. And again, we can, the students can now say there are three possible content I can watch, and if I watch this from three different angles, I will eventually get this, and we can suggest those content. Yeah. Again, our assessment and practice system is pretty much like this. We have seen this before. The idea is all students are different in their learning journeys, but we are giving them the same homework or the same test. So asking the right question is very important. It is not about standardization of a testing system. It's about being relative to the student, not being relative to the curriculum or the target curriculum. So how do we get there? Again, with the adaptive learning in the test taking, we can create very precise problems for each student using a template, and then say, here is a template. I can create hundreds of problems with the template. Which is the right problem for this student, this student, this student? I can do that given their current state of learning, right? So that is possible now. And we can create adaptive homework. Some get more homework, some get less homework, till they all get to the same level of mastery. Only then they can move forward, right? So it's the mastery level that has been fixed, not the what is being taught in the school. Another area is, I think we need to give them uh, enough ways of not just saying here is how you solve one problem, but they need to understand there are alternate ways to solve the same problem, and you can actually look at it and say, this is why this is a better solution. You could have done this, this, and this also, but this is the better way to solve the problem. Unless they see the entire path or the tree structure, they will not know why this path is better. So we need to tell them the path, not because textbook says so, but because it makes sense to them from a looking at all possible paths. They themselves figure out, yes, this is the best path. So how do we get to that level? Learning to think and not just learning to solve. And then feedback level, right? If I give them this kind of a thing and say, tell me ABCD, I'm not going to learn anything more about the student. But if I tell them this and say, look, here the student make this kind of a mistake, he put a minus sign here. On this step, the student made a mistake. So I pick that up in my state thinking and I reduce the score. And next time I practice this one concept. What is x cube minus y cube? And that's all I practice. He masters that. Then I give back similar problem and we look at the impact, right? So how do we do this at a step level? Step level feedback is very important, especially in mathematics and physics and wherever steps are important. So just to conclude, there are a couple of disruptions that are needed, right? One is we need to create a concept graph that says you teach this, after that, before this, before that. What is the weightage of this? Can we learn the weightage? Can we start with subject matter experts telling me what edges should be there between concepts? And then what should be the weight of those edges, right? Later, as I run this system and I collect data on millions of students, I can change the weights. I can even add new weights or remove some weights. So the graph will be there, it will get refined and refined, and we will know how the graph will be, right? And the graph will now improve the recommendation engine for curriculums. So concept graph is one infrastructure we need. Root cause analysis is one infrastructure we need, which says that the student is struggling with this, why? So we know the what, we need to know the why, and we'll say, look, it is because of this concept. And if I go back in the knowledge graph, in the concept map, I can say this is why he's struggling. Let me test him on this and verify, and then first make him do this. Automatically this will improve because I have done root cause. This is not possible today if a teacher is teaching 30 students. This is possible if a tutor is teaching one student at a time, which is not a scalable model. So we are basically digitizing a personal tutor, which can do all these crazy things at a student level. This is the state transition that will happen to a student, right? So he's not ready for a concept. When he has mastered all the prerequisites, he's now ready for a concept. When he has learned some videos, he's now ready to do practice. After practice, if he's not getting, he can learn from more videos, or he can go forward if he feels comfortable, or if the system thinks that he's ready for assessment, the system will take him to the next level, or it will tell him, no, no, you need to do more practice. And once he's done the assessment is failing, he needs to do more practice. He may need to come back and watch more videos. So all this is possible now, and this orchestration is possible by the teaching machine. For every student, individually at their pace, this is now possible, right? And this is how it will look in the classroom and hybrid environment. So for example, a teacher is teaching the right students their own proficiency segment. So we have done sectioning of the classroom based on the proficiency segments. So this group of students need exactly a particular concept to be taught, not according to curriculum, but their needs. And then she goes to the teaching machine and say, look, I have taught these 20 students this concept. Go assess them. Give them practice test. Go assess them. These students need to be assessed on this concept. That's what the teaching machine needs. It doesn't need from teacher what questions to give. It doesn't need that. The teaching machine should be automatically look at our question bank and come up with the questions. It will give the right, individual test, practice test and evaluation to every student, independent of the other student, for the same 20 students for this concept. They will all do it at their pace, and then the reports will get generated. That report the teacher will see. So teacher does not have to create question paper, correct question paper, generate this report. All this is coming from the teaching machine. The student looks at it, the teacher looks at it, and then decides, okay, here is my new proficiency segment now. Recluster the whole class, class sixth, into another five sections, five segments based on proficiency, and then pick the right thing, send the right teacher, and create a new timetable every week. So that is how the digital physical system will work if we allow this to work. Right? And obviously, education is one of the biggest big data problem. People say, you know what, education is not a big data problem, but if Google search works on click data, teaching machines will work on step level data. So if I did the math, and you can imagine, right? Amazon sells 30 million orders per day. That is the volume of data they have to learn from, right? Google, there are 3.5 billion queries per day. That is the data they have in their digital system to learn and improve Google search. Now, if you do the math and you look at every student solving, let's say, doing 5 homeworks a day, each homework they do 5 problems, each problem they do 5 steps, the number of data points that can be collected in an education space is far more than what Google collects in a day. I can collect 100 billion records of step level from all the students in the country, because see, we don't do Google search every day, or we don't do 25 Google searches every day. That is the amount of data we are talking about. Imagine 25 Google searches every day. If everybody does, that is the level of data we are talking about in education. The only thing is we are not capturing it. We need a digital ecosystem to capture it. If we can capture it, we can improve our education system far more than what Google has done in the last 20 years. We can take this to a completely different level. Yeah. All right. So let me summarize. So what does a purely digital education system will look like? It will be highly scalable. There is no need to worry about classroom sizes. There is no such thing. 30 students per class. There is no such thing. MOOC courses have taught us that millions of students across the world can learn from a piece of content. There is no such thing as a classroom size. That limitation is gone from our mind. Infinitely scalable, always available. This is not about 9 to 5 or whatever, 7 to 2. You can learn, other time you cannot learn. Digital system is always available. Whenever the student feels inspired to learn, it is available. So 100% available and highly personalized. It is not a generic system that is telling the same thing to every kid. It knows exactly curriculum, all those things can be personalized, right? So in that sense, this is my new digital school, which is around so this is the new digital school. The CMS system and the internet is the new library. There is no physical building. All content is available, and it's even better. It's available in all Indian languages. Imagine, and I'm sure government is doing projects around converting every nice content into all Indian languages. We need to work on that, but once it is available, we can tag every content and saying this is physics, this is the topic in physics, this is the difficulty level, this is the language, this is the teaching style. We can tag every piece of content and now make it searchable, personalizable to every student, right? Your MOOC courses are your new classrooms. So these classrooms are 100,000 students are learning from one piece of video anytime. So that is the thing. The teaching machines are the tutors or the teaching assistants for the teachers. These will take care of creating personalized homework, more homework, suggesting alternate content, all that they will do. Their goal is to make sure the student has mastered the concept that they have chosen to master, or the teacher has told them to master. And if that is the case, the teaching machine's job is to do that. And your new digital school is your tablet or your phone or your device. And we want to make sure that all kids have the right tablet. And this is the hybrid education system that we talk about. What I'm saying is, clearly, if we demarcate what can be done digitally, should be done digitally. So choosing the right next topic to learn is a digital problem. Watching the right video is a digital problem. Doing the right practice, homework, assessment is a digital problem. Taking the right assessment is a digital problem. Can we do all this digitally at home, at the student's pace? Obviously, we need right incentive structure, gamification, and all that. But digitally, what can be done? And when the student actually comes to the so-called schools, what do they really do is they don't watch a teacher giving a lecture because they've already watched the content. What they do when they come to school is to clear the doubts. They talk to the right teacher and say, I need this help. The teacher is only teaching, the sections which are very precise. So the student can go to this section, that section, or the student is assigned the right section to go to and say, I know that you're weak at this. This is the section that is going to cover this today. You need to attend that classroom. We'll make it very agile, right? So clear the doubts, attend the right sections. You go to school to talk to teachers one on one, right? You get other students who have mastered the concept to teach you, because they have mastered it. They can explain it to you also. So we can now scale. So a student is not just learning, she is also teaching somebody what they have learned. And for me personally, that is the real proof of learning, that can you teach it to somebody. And if we bring this element, right, teach to learn and learn to teach, both. And that can happen in a physical school. Only teachers don't have to teach. The students who have mastered a concept can teach the same concept to the other ones. And now imagine classrooms are filled with teachers teaching something and advanced students in that concept teaching that concept to other students in a one to one or one to many settings. That is a new education system. They go to school to solve problems together. They don't sit in a classroom and listen to a lecture. They work around a table, they take a project, they brainstorm, they do hackathons, they solve problems, and they learn how to work in a team, how to cooperate with each other, how to appreciate what everybody else is bringing to the table. And it's not about me, it's about us. They learn teamwork and they learn cooperative problem solving. This is what they need to do in our schools now. They don't need to just listen to a teacher. That they can do at home. And they come prepared because they have to solve this problem, and they need to learn whatever they need to learn so that they can solve this problem in school. And they go to school to do sports, do plays, drama, debates, music, science lab, wherever physical interaction between students to students, students to teachers, students to labs, students to football field, students to music instruments, wherever that physical interaction is needed, they go to school. Wherever digital part of education can be done, they do it on themselves. And if this hybrid education system can be thought about, and we are all ready, we are ready from an NEP point of view, we are ready from a technology point of view. So that's all I had today. And thank you so much for your patience. And maybe I can take a few questions. We have 5 more minutes left. Thank you all.
Thank you so much, sir, for your wonderful session. I'm sure everyone will be very happy to learn all these aspects of AI for educations. Now, participants who are interested to ask any question, please ask them directly, or you can type your question in a chat box. If anyone has any question,
Or ma'am, you
please.
can collect the questions and send it to me. And
Okay, sir, no issue. Okay, sir, we'll collect the question and send it to you.
okay, no issue. Thank you very much, ma'am.
Thank you so much,
And I
sir.
would love to
Excuse me,
interact
ma'am.
more with the right faculty and the right leaders. Thank you.
Excuse me, Jayashree, ma'am.
I
would like to interact with you also because this is my research topic. I done my PhD on personalized e-learning.
Sir, can I have one question?
Yes.
Yeah, Jayashree ma'am, can you ask so the guest speaker to share their email ID, please? If they
Uh,
like and
yeah, ma'am will share his email ID with you.
yeah,
Don't.
yeah, sure. Thank you.
Sir,
Yes,
will
yes.
collect
Please
all
share
the
my email
questions
ID.
and mail
Whoever
it to
wants
you.
to interact, they can interact. Thank you. Yes. Thank you. Thank you.
Thank you, sir.